Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy, and today I have something special for you. One of my fellow navigation enthusiasts, ProtoThad, is joining me today, and he was recently on the Nathan Oakley show. So I thought maybe we'd go over that a little bit. Hey Thad, how are you today?
Oh, not too bad. How about yourself?
Oh, not too bad, not too bad. So I understand you tried to bring Nathan some knowledge the other day. Do you have do you have any experience with sextants?
Oh, a little bit, yes. I learned to sail back in the mid 80s, and as part of that, learned celestial navigation. Of course, GPSs were not quite as available and prevalent back then, so that was a thing you did if you were sailing, particularly on the ocean. So I did learn how to do that, and I did it, used it a fair bit, both in the 80s and in the 90s. But then, of course, less and less as GPSs were more of a thing that was available on most boats. Though I still have kept in practice, it is still a thing I really enjoy. I kind of consider it a hobby. I went out and did do some sextant sites just a few days ago off here in Lake Michigan. So yeah, I do consider myself, quite the celestial navigation enthusiast.
So you've worked with MC Toon as well, haven't you?
Yes, I helped put together the challenge that they did for his channel not too long ago. We basically kind of worked together on that and found a book called Hawaii by Sextant, and I kind of poured through it and picked out some specific examples I thought were pretty good, that would work well for the test. And then I put together the questions. I sort of framed it in a way that someone who understood celestial navigation could work through them. So
Uh,
that was my involvement there.
I took that test.
Yes, you did, and I saw you did quite well. You got it within 5 nautical miles. I was very
Yeah.
impressed with that.
Well, it's not too bad. Even a blind squirrel gets a nut sometimes, as we used to say back south. But I'm not a sailor. I'm a pilot, and I do GPS work and I do long distance navigation as a pilot. But I've never really had too much in the line of sailing experience. Now, by sailing and learning to sail and such, and you mentioned the ocean, I take it you're not sailing a sunfish on a 60-acre lake.
No, I mean, nowadays I'm a little more of a day sailor. I don't get out on the water as much as I'd like, and it is kind of smaller boats when I do it. Back when I did actually use celestial navigation more, I was getting on some larger boats, including some out on the Pacific. So a pretty nice sized one with a friend I had out there that invited me to help him do a rather significant several week journey out on the Pacific, and that was a time when I really got some good time in with the sextant.
So you're actually talking about making a cruise that's several weeks long on the open ocean.
Oh yeah, yeah.
Would you say that your life depended on your ability to navigate properly?
I mean, we had backups, but yes, I mean, if you don't navigate properly, you will get lost at sea. Like one of the more significant things I did was in the late 90s where they did have a GPS unit, but I did use the sextant the entire time and compared, and that was actually kind of neat where I got to compare it to the GPS and actually see that, yes, I am actually getting it within a certain number of nautical miles of what the GPS says we were, and kind of confirmed that I was doing it right. Back in the 80s, I did some sailing where it's like you didn't have a GPS. You sailed and you did the fixing, and then if you got where you thought you were supposed to be, that was your validation that you'd done it correctly.
Yeah, if you didn't get lost at sea. All right. Well, let
Yeah.
me ask you. Let me ask you a kind of a navigation question here. When you're dealing with a sextant, what is a reasonable accuracy with a sextant?
Well, it can be pretty variable. You can, get it down within a nautical mile, even less if it's a good day and it's lucky. But it's typically you get it within a few nautical miles, because you have various things that can throw it off. You of course weather, operator error, amount of refraction that you're getting on any given day.
Mm-hmm.
So if sextants will not get it as accurate, say, as a GPS.
Yeah.
But if you can get it within a few nautical miles, you're actually doing pretty good.
Okay.
On a bad day, you might get it within 20 nautical miles, and that's just the best you can do. The next time around, you might do it better, and you get yourself back on course. So.
Yeah, but I mean, even being 20 nautical miles off, it's not an insurmountable error, is it?
Oh, no, it's like you're talking about if you're navigating across an ocean. putting it kind of in the context of how people used to do it, centuries ago. If you're navigating in the ocean, eventually you're going to get to the shore, and then you can use landmarks. If you're getting it within, 30, 20 nautical miles, you're getting close enough, you can start to recognize landmarks and then kind of like, scoot yourself one way or the other and get yourself closer. So, getting it within 20 miles is actually, not bad, considering weather can be very variable when you're out there.
Yeah. So, there's two basic techniques that you can use with a sextant, I think. One is if you can get close enough to at least see where you're going, that's a good day. All right. If you can navigate close enough to a point that you can actually see your destination, like the entrance to a port or a lighthouse that leads up to the port or something. Or the other thing that you can do is you can, say you're sailing across Lake Michigan. You seem to be familiar with that. So if you're going, from west to east across Lake Michigan, you're trying to head over to Ludington. One of the things that you can do is you can either aim a little bit north or a little bit south. So at least you know what side and which way you have to turn when you hit the shore, and eventually you'll find Ludington.
Sure.
All right. So here's the thing that I was curious about. Now, with you actually have a wealth of sailing knowledge and experience, and a lot of experience with a sextant. This is a golden opportunity. Now, when you have somebody like me that's an amateur that, I somewhat know what I'm doing, but there are just so many more things that I need to learn. If I had an opportunity to spend an hour with you, I think that I would spend that entire hour with my mouth shut, other than to ask maybe a pertinent question or a clarification once in a while. But I would really want to learn from somebody with your experience to teach me how to use a sextant, because you're just a wealth of knowledge, and I'd like to absorb some of that. That's the way a normal person, I think, would approach talking to somebody like you. Is that the experience you had on Nathan's show?
No, unfortunately not. I wasn't expecting them to just give me their rapt attention and ask me questions, but I thought they might at least be willing to not turn it into a dumpster fire. Well, okay, I pretty much expected it was probably going to become a dumpster fire, but just based on what I've seen in the past. But I was hoping I would get a chance to talk to them about their interpretation of celestial navigation. I went in there, and I even said this in the Discord server. I was not going in there to try and convince them of the globe. I know how pointless that would have been, but they've made some claims about how celestial navigation is supposed to work on a flat Earth, and I had looked at that and had some questions. I was curious about some of their interpretation and how they might respond to some of my things I had noticed about it, and was hoping I could bring that to him. And actually, I tried to bring some of these things up with Brian's Logic, a few weeks before that on his YouTube channel, and he at some point said he didn't want to talk about it there anymore. That if I wanted to talk about it anymore, I had to come on Nathan's show. That is what led me to coming on Nathan's show. Okay. And so it took us a couple of times. He canceled a couple of Fridays because of different things. And so that was sort of the lead up to that. So my whole point was I would have preferred to talk to just say maybe Brian or 10th Man, since they were the ones who have been talking about how they see celestial navigation working. And I was curious to kind of talk to someone who has a very different view of how I understand it works from my 30 years of actually, doing it. So, and that's really what brought me to this whole thing to begin with. This whole flat Earth thing was I saw a video, I think it was by Mitchell from Australia, talking about sextants only work on a flat Earth. It's going to pique my curiosity of I'm wondering how anyone would think that based on what I know about how it works. And so I was just coming in to say, I would like to hear someone explain how they think it worked on a flat Earth, because this is a very, curious, different idea. And so that was kind of what led me into this whole thing, not trying to pick fights with anyone. I just really wanted to have a conversation with some people about this kind of curious idea.
Well, Thad, one of the things that I've always noticed is that they like to find some sort of a slogan, and then they make an argument by slogan. And that is, one of the more recent ones that they do is something about, having an angle next to a curved adjacent. Have you heard that? All right.
Oh, yeah. Definitely heard that one. Yes.
All right. Well, right here in my hand, I have a drawing compass. Are you familiar with this device?
Oh, yeah. I used one just recently to do a demonstration of celestial navigation on a globe.
Okay. So here's a drawing compass, and we have a pivot right here, and we could call that the vertex of an angle. and then you have one arm that goes out and another arm that goes out. This is just a spacer right here. But would you say that there's an angle between those two?
Yeah, you could call that an angle.
Is that something that we could measure, perhaps?
Oh, yeah.
All right. Does it care what shape? Does it care what shape it's next to? So, for example, if I held it up against this and touched it to the surface, does that change the shape of that angle in any way?
Of course not.
Okay. So where's the curved adjacent on that angle? Is there a curved adjacent?
Of course not. That's a nonsense statement. So.
All right. Do you, by chance, which of these is the adjacent? Which arm is the adjacent here?
Right. Well, when I hear them say adjacent, I assume they're talking about a triangle, and it's because you have an adjacent side on the triangle.
Yeah.
So I think that's kind of silly. It's like, well, you just have an angle,
There isn't an adjacent.
You don't have a full triangle. So
doesn't matter if I hold it that way. There's still not an adjacent there. So
right.
Okay. Now, when we look at an object through a sextant, all right, what do we see? Do we see the horizon and then we see a star and then, we use the sextant to bring them together to find the angle between them? Is that basically the way a sextant works?
Yeah, you've got your horizon mirror and your index mirror, and one of them you view the horizon, the other one you're viewing the star, and then you adjust so that you're bringing your star or the sun or whatever you're viewing, so it's down touching the horizon. And when you get there, then that you could read your angle off your sextant, and that's telling you your angle of elevation off the horizon, which of course then you have to make some adjustments to actually get it off the horizontal, off the celestial horizon. But yeah, that's basically it.
All right. Now, the other day, apparently they zinged you pretty good on this. They claim somehow you don't know what an arc is. Now, I just wanted to add something to that. I was talking to Don Gio today in the asylum, and he was bringing that up and thought it was very funny you didn't seem to know what the arc on a sextant was. I told him that was absolute crap. I know you know what an arc is. After telling him what the arc was, and he goes, well, you apparently know how to use a sextant, but Thad doesn't. And I said, no, Thad does. He had no idea what context you were talking about, and there is an arc on a circle. So we got to talking a little bit, and we got to talking about doing measurements. Can you use mathematics to do a measurement on a distance? Well, no, you can't. You've got to do a physical measurement. Oh, really? What is the accuracy or the margin of error on a physical measurement? He goes, well, I don't know what you know. He said, well, I don't know what you mean by, a degree of error or anything like that. And he says, okay, well, I just want to let you know, I'm going to tell Thad you don't know what an error means in measurement. So I thought we'd get a little laugh out of that at his expense. Mm-hmm. But in any event, I recorded that show with Nathan. I was in the background. I was, of course, suppressed because, they didn't want me speaking. And anytime I ever post anything there, QE immediately deletes my posts and puts me in timeout because, the thing about QE is that he never likes to be fact-checked by people who actually know what they're talking about. Mm-hmm. And, he's got the emotional maturity of a 12-year-old girl. And I've seen some 12-year-old girls that had much better thought processes and much better grace, shall we say, or conversational ability than people like QE. So I thought I'd give them a little boost there. So let's go ahead and have a quick listen to QE and Nathan on the show right at the very beginning. Now, they were doing housekeeping, and they were putting out their liturgy, which is, their little chant that they do at the beginning of every show to reaffirm the faith. It's very much like, what we do in church sometimes. We make our statement of faith when we first walk in the door. That's the start of the service, and that's the way that Nathan approaches this because Flat Earth basically is a religion. But I understand that you tried to join in and maybe answer one of the questions. And Nathan... And Nathan was all for it, but then we had a little bit of an interjection. Let's go ahead and have a listen.
Sure.
But is there any evidence you can have an elevation angle acquisition from a curved adjacent, i.e. sphere Earth?
No, absolutely impossible. Has to have a horizontal baseline.
I'm not hearing any objections. Shocking. Any evidence of axial rotation?
Do I get a chance to object?
Of course, that's the point of an asking.
You get your chance. You get your chance. You just wait. There are charges brought against you. You just chill out.
Yeah, I see them posted.
Looks like we'll get to that later then. I was more than happy for you to answer any of the housekeeping questions. But obviously, there's charges and I haven't levied them. QE has, so,
I was very curious when I heard that. What in the Sam hell is he talking about leveling charges against you?
Well, it's interesting. I was impressed the extent they went to find a distraction from actually like talking about anything meaningful or answering questions. So they brought up some comment I had made. And I honestly, it's like when they were saying, I'm like, what is this? Because I didn't realize they went back actually more than 2 months, 2.5 months basically, to a comment I made on a different Discord server and pulled something out of context to try and say that, oh my God, I'm this like horrible liar who actually thinks the Earth is flat. And so now I'm lying when I'm coming at it, saying I'm a globe believer. And that was what they tried to make the entire show about. So at first I didn't even know what they're talking about until I actually saw the quote and saw the date on it and realized, oh, this has got to be from this other server I used to be on, which was when I first got pulled into this whole thing. When I saw that video, I think it was from Mitchell in Australia, talking about how sextants only work on a flat Earth and use triangulation and all that kind of stuff. So I started out asking some people on Facebook about it. I got an invite to this Discord server, and I went on there asking about this. And I went in, not there to pick a fight, not to convince anyone about the globe. It's kind of like the same thing I was trying to do on Nathan's channel, to ask them about their belief of it working on a flat Earth. And so I came in with that framing and asking specifically about what I had seen in this video. So when I'm saying on there, we all agree, I'm talking about we all agree this is what the video says. We all agree what the flat Earth argument about sextants is. Nobody thought I was a flat earther because I had to pick a role when I came on that server saying I was a globe earther. The color of my name in that comment declares that I am a globe earther. So the people there knew that's what I was. I did say, hey, I'm trying to be open-minded about this. I'm going to try and look at it from your viewpoint, but this is what we're talking about. And in response to some other comments, I said, oh, no, I'm not saying that, this is the globe earth argument. I'm saying we agree that in this case, this is on a flat Earth. There's a triangle. Now I want to explore how that would work. And if you notice the part of the comment that they ignored, I'm pointing out the problem with it, that to triangulate, you need the height to the star, and we don't have that. So they completely ignored that part of it. They just had to focus on the fact I seem to be saying that I believe that the Earth is flat. So that was a lot of fun. I'm like, kind of running with that, and that was their excuse for turning it into a dumpster fire.
Well, two things that you have to be aware of. First of all, there's a psychologist that studies conspiracies. His name is Dr. Lee McIntyre. He's a PhD level psychologist and philosopher, actually. And he wrote a very interesting book on how to talk to a science denier. And he attended the 2018 Flat Earth International Conference, specifically to learn how to interact with science deniers. And he considers flat Earth the ultimate in science denial. And he's got 5 characteristics of science denial. And I'm going to run through them real quick because, you're probably familiar with it. It's the way that I always approached it, but he really crystallized it well, and I want to give credit where credit's due. The first characteristic, first and foremost, is cherry picking. Second is conspiratorial thinking and belief in conspiracy theories. The third is the promotion of fake experts over real experts. The fourth is poor scientific logic and reasoning. And the fifth is The fifth is an inappropriate expectation of perfection from science. And I think that we've already seen a couple of those. But do you know why they went back 2 months to look at all this stuff about you?
I don't know. I must have got underneath QE's skin pretty good if he wanted to put in that much effort. But
You did. I mean, when QE sleeps at night, as soon as he closes his eyes, there I am, because that's how much I'm in his head. And I suspect that you're probably going that route too. But actually, the real reason that they go on the attack like that is they want to start off by putting you on a defensive. They will use a straw man argument, or they'll cherry pick a quote out of context, as they did with you. But, rather than address the actual issue that you're there to talk about, because they know that they can't counter it, what they're going to do is they're going to try and somehow find a way to put you on the defensive, and telling you that you are up on charges for this quote that you did 2 months ago on 24/7 Flat Earth Discord or wherever you were. Is designed to get you off of your game, to distract you, and then try and get you on the defensive so that they're in control of the situation. Now, how would you counter this?
I thought it was kind of, it worked in my favor in a way, that he was framing this as some sort of trial, and that then I had the right to bring my defense evidence, so they put that diagram up that I never expected them actually to do that. I think it was one of the people in the Discord volunteered, like, oh, sure, I can post this image. So that actually worked out better than I expected. But
all right,
please go on with what your strategy would be. I'm very curious.
Well, one of the things that I do is, oh, you're going to interrupt me? Well, then I'll just quietly wait here until you're done.
Mm-hmm. Yeah.
Am I ready to talk now, Nathan? Is it okay? Do I have your permission to talk?
Mm-hmm.
Are you sure? Okay. The other thing is that I don't allow them to put me on the defensive. I think that one of the things that, one of the approaches that you could use with something like this is just, oh, okay, well, that's nice. Now I'm going to go on with what I'm talking about. But in any event, let's go ahead and have a listen to this a little bit more.
I stand under him in this regard.
Let's just bypass this. Let's get to the charges, because I feel like I need a shower already, right? So
Okay. Let me preface what QE's about to do. So we've got a guest who wanted to show us how we could have curved adjacents, etc., etc. And before we've even got anywhere, we've had lies in the pre-show. Now, as a result of that, I've had to produce evidence that I had privy to. So I've basically completely undermined QE. Hopefully he won't tell me off afterwards. But with that being said, the audience is now in the know. Go ahead, QE.
Your Honor, I'm going to have to garnish your wages.
I know, I'm sorry.
So, listen up. It's going to be me. I'm the prosecutor. ProtoThad, you're the defendant. So no one should be talking except me and you and the judge. That's the distinguished Nathan Oakley, his worshipfulness. So, we got 2 charges against you. They will be evidenced by exhibits 1 and 2, respectively. Charge number 1, mathematical fraud. And charge number 2, Dunning-Kruger double-speaking dipshit fraud. Your Honor, could you please post to the jury exhibit 1?
Done.
So, ProtoThad, on 4 February, you said, but here is this thing. We don't actually use a triangle or do triangulation when we do celestial nav the globe way. So there is no adjacent side, curved or otherwise. 4 days later, on February 8th, in the year of our Lord 2022, Brian and 10th Man keep saying it can work on both models and that the globe version was reverse engineered from the flat Earth. But that doesn't actually work mathematically. The angles you get on flat Earth will never be the same as what you read from a curved surface. It is basic trigonometry. I got that highlighted, which seems to be a blind spot for them. Really, blind spot.
Okay, I agree with that.
I'm not done yet. Oh, you agree? There is no agree, disagree. This is what you wrote.
Well, Thad, this is something that I've heard from QE before. You can't have trigonometry without triangles. What in the Sam hell is he talking about?
Well, yeah, I mean, it's obviously we do a lot of things with like the unit circle and angles and curves that we don't directly address with a triangle. But I think he's kind of even missing the point here in that I am addressing both models with this, both the flat Earth model where they claim they're using triangles and triangulation, and the fact that we're getting these angles just off of the fact that we're that we're on a curve, and to address that, we will use trigonometry when evaluating the flat Earth version, because that's how they say it's working. They say they're using triangulation. But basic trigonometry, using their model, using triangulation to get the angles, comes up with values that don't make sense. So basic trigonometry shows that the angles you get are nonsense compared to what we see in reality. And that's the part they're missing. They are the ones claiming that you're using triangulation to get the distance to a star's GP. Using trigonometry to actually examine that shows that the values you get don't work. And that's the part he's totally not getting there.
Not long ago, I did an exercise in this myself, and that is that I went up on the whiteboard behind me, and I wrote out 4 situations where you had, in each situation, you had a number of sticks in the ground, 4 or 5 of them. And on one situation, the ground was flat. On the other situation, the ground was curved. And then I compared that to a local sun with divergent sun rays or a distant sun with parallel sun rays. And I looked at what you would get with shadows in all 4 cases. So, for example, if you had a flat Earth and you had parallel sun rays from a distant sun, every single shadow would be the same because the sunlight's coming in parallel. All the shadows are perpendicular to the ground, which is flat. Therefore, all the shadows will be the same. That's not what we get on Earth, period. So we can, rule that out. With a local sun on a flat Earth in the same situation, the shadows would all be different. There would be one, say, directly underneath the sun and then progressively out. This is basically the Eratosthenes experiment with multiple observation points. Well, you would have different shadows on each of them. However, if you did the trigonometry, the basic trigonometry, they would all triangulate back to the same height of the sun, the same h. That does not occur. Blue Marble Science, B-Ball for Life, and I have all done the Eratosthenes experiment from Michigan, from Tennessee, and from Hawaii. And we all came up with our location. We all came up with the same size to the Earth as far as the radius goes, but we all came up with a different elevation to the sun. So we can rule that out as well. Now, on a curved surface of the Earth with a local sun, you could easily predict the shadows. And on a curved surface of the Earth with parallel rays of the sun, you could also predict the shadows based on your locations. As it turns out, the one that matches reality is a curved surface with a distant sun. And, that's just going through the different possibilities and evaluating them equally and by the same standard. That's, I think, what you were talking about, weren't you? You were basically comparing and contrasting two different models of the Earth. And
Absolutely.
Okay, and that's the way science works.
And it's what I touch on in that diagram I put up, and it's also Brian's logic did a thing on the angles to Polaris, and he's got this idea that it's the globe model was all just reverse engineered from the angles that we're getting from an actual flat Earth and the local sun and all that, not realizing that you can do that trigonometry to disprove that. That's why I say they have this huge hole in their understanding of trigonometry, because if they did understand the trigonometry, they could see that those angles don't work.
Correct.
They throw the word out there like it's some magic charm. They can just say trigonometry those triangles exist without actually knowing any of the trigger identities or how to apply them or any of that. So I tried to make my diagrams such that even without understanding the trig identities, you could visually see that the base of that triangle kind of debunks what they're trying to do in their model. So please go on.
Well, the thing that I always like to hit them on, just to demonstrate that, is I always ask them, okay, well, your distance to the Black Swan oil rigs is 9.42 miles. Is that globe Earth distance or flat Earth distance? And they go, huh? And it's, like a globe Earth distance from Google is a great circle distance, which is the distance across the surface of a sphere. If you want to do a flat Earth distance, you have to do a triangle. So, for example, you could use one, the one that I like to use a lot is, Perth, Australia. We know where that is. We know the exact distance from Perth, Australia to the North Pole. So if we create a triangle from Perth, Australia to the North Pole, and then down to Sydney, Australia, and we also know the exact location of Sydney, the coordinates of it, we can calculate, using the law of cosines, the distance between Sydney and Perth. And it comes out to 4,400 nautical miles. Now, if we do the Haversine equation, using a radius of 3959, all right, we can calculate out the great circle distance between Sydney and Perth, and it comes out to 1,778 nautical miles. Then we can have Wolfie or somebody else down there, and I've even done this with flat earthers that live in Australia. How far is it from Sydney to Perth? And they goes, well, it's a little over 3,000 kilometers. Well, that works out to 17,077 nautical miles, which matches. The globe Earth distance does. So you need to be able to, but the point is they had no idea what the law of cosines were. They had no idea how to even begin to calculate a flat Earth distance where all triangles have 180 degrees. You see, they have an issue that they seem to believe that all trigonometry or all geometry is Euclidean geometry. There's non-Euclidean geometry too, just like you have Newton and you have Einstein. So, for example, in Euclidean geometry, a line is basically a segment between 2 points that has neither width nor depth and doesn't deviate. Now, on non-Euclidean geometry, the shortest distance between two points is defined as a line, and that's along the surface of a geoid, or the surface of the object. Now, if it's a flat surface, that works, the non-Euclidean definition works just fine. It's a line is the shortest distance between 2 points on a flat surface. It's also the shortest distance between 2 points on the surface of a sphere, which is why a great circle is a line. But one of the things that they love to do is they love to find something that they cherry-picked at the height of their academic careers, which for QE appears to be about the 7th grade. And he would say the scientific method has one and only one definition, and it's the definition that I'm giving you. And there are no other legitimate definitions of the scientific method. So therefore, astronomy is not science. Okay, you've seen that before. The other thing is, what is trigonometry to you in the 7th grade? It's the study of triangles. All right. Now, as you go on into high school and maybe even into college mathematics, you learn that trigonometry is not just directly involving triangles. You can use trigonometry on the surface of a sphere. That's called spherical trig. Just like you can have a spherical triangle, which has more than 180 degrees internal angles. Or you can have a hyperbolic triangle that has less than 180.
Oh, yeah. I mean, in my job, I will use trigonometry to translate things between coordinate systems where I am never directly using a triangle. I mean, the Haversine formula is a great example of that, where you're getting that distance across the surface of a sphere, you're at no point ever like directly doing with a triangle. You can, of course, if you want to like derive the Haversine formula. If I had needed to sit down, didn't have it in front of me, and I needed to derive the Haversine formula, I could do that. Probably I'd sit down and sketch out some circles and draw a couple of triangles inside that circle to kind of think about which trig identities I would use. But in the end, I would have something where I'm never directly applying a triangle.
Correct.
But yet you're using it to like, get your answers by using trig identities.
Correct. And trig identities are different than just calculating triangles. You use trigonometry and statistics. You use trigonometry and finance and a lot of other things that you use trigonometry for that have nothing to do with triangles. Now, the Haversine equation, which is another thing that really freaks them out. The Haversine equation doesn't involve the radius in any way, shape, or form. It simply helps you take two coordinates. And I always ask them if they believe latitude and longitude are real things. Oh, no, it's a man-made construct. Great. Pull out your phone, screenshot your current coordinates, and see if I can't send you a picture of your house in about a minute. Oh, no. No, I don't want to do that. I don't want to dox myself. You're right, because you know that goes back to one spot on the Earth, your house. So with the Haversine equation, what you do is you take two sets of coordinates on the surface of a sphere, and you determine the angle that is subtended between them, the two spots in the center of the Earth. Then you take the Haversine formula, and you take the Haversine, and you have a couple of other terms that you have to introduce. One is the radius of the sphere, or the radius of the Earth, and the other is the distance, the great circle distance between 2 points. And they always say that, because they heard of the Haversine formula, probably from watching one of my videos. And they know that the Haversine formula has something to do with the radius, so therefore they can throw it out. Well, A, I've measured the radius 5 different ways. I'm pretty confident I know what it is. B, you don't need the radius in the Haversine. If you know the actual ground distance between 2 points, you can use that ground distance to calculate the radius. And guess what? It matches Eratosthenes and Al-Biruni and Kepler and Aristarchus. Why does that happen? Because that's actually the radius of the Earth. But if you simply know the distance between Sydney and Perth, for example, you can find the radius of the Earth. You don't need to know the radius of the Earth in advance. I don't know the radius of that little globe that I brought up a minute ago. I could find it, but I don't know what it is offhand, and it still forms an angle when you hold the compass up against it. Mm-hmm. So, I mean, have you seen that a lot? Do you see a lot? That's basically poor scientific reasoning, number 4. Cherry picking, number 1. And, the other thing is, well, how come the distance to the sun has changed? Well, that's in, perfection in science, because our measurements gotten any better. So shall we listen to these guys here a little bit more and see how they're approaching this, and then we'll talk about it for a minute. And then I'm going to probably let you go, because this whole thing kind of goes along that vein, doesn't it? Mm-hmm. Did they ever once give you the impression they actually wanted to know anything about the sextant?
No, of course not.
Did they ever once indicate that they wanted to know the truth about anything?
No, of course not. I mean, it's kind of funny though. It's like I do see Brian and 10th Man. They're out there reading these documents, and they seem like they're trying to get to something. Of course, they're trying to take the actual globe-based process that they're reading about and shove it into their flat Earth interpretation, and coming up with that sort of nonsense argument that I made my diagram about. And so to some extent, it's like, my whole purpose on going on that show is I wanted to put some information, not really in front of Nathan, because there's no actually talking to him about any of this, but I wanted to put it in front of these guys who are actually looking at the documents and have them think about that. And I feel like I accomplished that. And in fact, I've actually had some dialogue with Brian in private Discord messages since then. I don't know if he's
Brian's not a bad guy.
No, actually, I think if you sat down and had a beer with him, I think he'd be a good guy. I think, unfortunately, in that toxic environment on Nathan's show, I think that's probably not the best environment for him to be in. But that's just my opinion. Oh, yeah. I mean, I would love to be able to sit down and even 10th Men, I would love to sit down and talk to these guys about this stuff, not beat them over the head and try and convert them to the globe or anything, but just actually talk to them about how they think about this. Because celestial navigation is a topic I enjoy. And I love talking to anyone, even if I feel like they have some misunderstandings, maybe especially if they have misunderstandings, because then it kind of lets us get in and actually explore that part where we disagree.
Well, you know, I've offered to have 10th Man just come on my channel. You know, last summer I had Brandon Toy. I don't know if you ever heard of him before. But last summer I had Brandon Toy on my channel, and we went over the Black Swan and actually looked at the images, which nobody in Flat Earth has ever done. And calculated how much of that oil rig was missing. We calculated where the horizon was, but we kind of went through everything. Now, he didn't necessarily agree with it all, but we had a very nice conversation. I think we could have a nice conversation with somebody like 10th Man, or who's the other one? Adam Meekins. You know, and I'd like to invite them to just come by and have a nice friendly conversation, you know, with you and me, or with just you. And I'll just sit down and be quiet and moderate. But just to try and work through some of this stuff with them. And that's an invitation that I'd extend out to them. But
yeah, Adam Meekin, I think Adam Meekin actually understands the globe viewpoint on it better than any. I've heard him articulate it better than anyone else on there. Now he may not believe it, but I think he at least has read the documents and understands what the argument is. So that would be an interesting conversation to have. I mean, that's someone I certainly wouldn't mind talking to.
Yeah. Now, the other thing is that, you know, the problem that you run into is that I can read a book and not understand it. I'm sure that you've done that as well. You know, I mean, I'm reading a book on differential equations, and I've got no damn idea what they're talking about. But, you know, I understand. But I speak the language. I speak the language, and I understand the words. But between reading them, they just get lost up here somewhere. And I think they're falling out of my ear because
differential equations almost broke me. That's a tough course.
It broke my roommate who was going into electrical engineering. It broke him, and now he sells cell phones. But in any event, you know, Adam Meekins actually tried the challenge on the sextant. Do you know where he had the boat?
Yeah, I actually kind of took a look at that and made a graphic based on it, which showing how far apart it was. It was over on like the coast of Mexico compared to being.
It was the Sea of Cortez.
Yeah.
Do you know why it was in the Sea of Cortez?
Well, I think they did their circles of equal altitude on a flat map, on like a Mercator map or something like that.
No,
that wasn't it.
No, he cheated. And what he did was, I don't know if you did this intentionally, and if you did, it was a Bob and Wolfie level devious trick. You said specifically that ship's time was GMT -7. I am GMT -4 during the summer.
Sure.
That was California time. It wasn't Hawaii time. The ship was on California time.
Right.
And his longitude was based on California time, so he was right below California. That was a trick that needed to be looked at. Because you almost screwed me up with that one. I'm saying, well, 7 hours, it's supposed to be over by Mexico, but he's over by Hawaii. That doesn't make a damn bit of sense.
Yeah,
that was devious.
In retrospect, I thought about, like, maybe for someone who's a little more of a novice at this,
you shouldn't have done that. You shouldn't have done that with flurfs.
Yeah, but it's like if in reality, when you're out at sea, you know, you don't necessarily have your watch on. You don't want to keep changing it.
It's not set to local noon.
Right.
It was sent to his port of departure, and you had to actually know what was going on to pick up on that.
Yeah.
And I think that you obviously see I picked up on it.
Yeah.
And I thought that was admirable.
Well, it's like, and I think, you know, hopefully, you know, since we didn't give you any dead reckoning information,
None.
That's why I said within 1,200 miles of Hawaii, so people could at least know they're kind of, you know, could have a starting point to kind of narrow it down to.
Well,
And that should have been enough to like kind of get people thinking about, okay, what am I doing wrong on this if they got way outside that.
It was a little more challenging than I think that it was let out to be. You have to actually understand celestial navigation in order to answer it. But within 1,200 miles, when you do your great circles, and I did them on Google Earth, by the way, just for fun. And there are 2 points that are possible. One is by Hawaii, about 120 miles off Hawaii, and the other is just south of Spain in the Mediterranean. So if you say within 1,200 miles of Hawaii, it's not the one in Spain. I often say that. Yeah, I always say that when you're dealing with celestial navigations, especially at 2-star fix, you're going to get 2 points, one of which is not possible. So, for example, if it comes back the Bahamas and Hudson Bay, if you see palm trees, I don't think that's Hudson Bay. And, and likewise, if you see polar bears, unless it's in the Nassau Zoo, I don't think you're in the Bahamas. Well, in any event, that was kind of some of the stuff that I wanted to go over. I don't want to keep you too long. Do you have anything else that you wanted to add? Is there anything else in this video that you would like to go over in particular?
I guess not. I mean, obviously it was kind of a dumpster fire.
Yeah.
I came out of it thinking like, well, I never really got to, ask my questions. If I didn't find out until afterwards, because I was in Discord and not really seeing the screen. They had put up that graphic of mine and left it up for like about a third of the show. Now I realized because they have that sort of that blind spot with trigonometry, they don't understand that the debunk of their interpretation of celestial navigation was right up there on the screen for everyone.
Which one was that, by the way?
That was the one where it shows the triangle. Yeah, it was the first one. It's the triangle where you've got the angle, the complementary angle is 25, and they're getting, the nautical miles is 1,500. But then if you double that angle up to 50, well, by their interpretation, because they're taking it right from the actual the celestial navigation books, well, that means it should double, the base of your triangle should double to 3,000. Of course, well, you and I know trigonometry, right triangles don't work that way.
No, they do not.
Like if you double that complementary angle, the angle down below it, the base of your triangle is going to more than double. You need to,
Here's, by the way, there's the
image,
image right there that you're talking about. And,
right.
Here's the classic thing that I do. Let me go ahead and get rid of my screen here. But here's the classic thing that I do. I live at 45 degrees north, roughly. So my distance to the North Pole is 2,700 miles, nautical miles. And that means that if this is 45 degrees, that means that this height must be 2,700 nautical miles. Now, if I go another 45 degrees down to 0 degrees, I'm just extending this out twice. And I drop my angle here down to 26 degrees. Yet on the Earth, it's 0 degrees. That absolutely debunks the possibility of a flat Earth. The other thing that it does is the 60 nautical miles per degree, which is 1 arc, 60 arc minutes per degree. That is a spherical angle measurement. It's not a distance across the ground.
Right. And I brought that up.
An arc minute is not a distance, it's an angle. And it changes, the length of an arc minute changes with the length of the radius of the sphere that it's being calculated from. It just so happens that on our Earth with a radius of 3959, sorry, I don't have the nautical miles right in my head, and I think it's, I'm not even going to make
it's 21,000.
Yeah, it's like 3440, I think, nautical miles.
Oh, you're talking about the radius? Yeah,
the radius.
I actually, it's about 30. I forget the number off the top of my head either, because you're working with the circumference. I know the circumference is 21,600 nautical miles. That's how basically 60 arc minutes times 360. So and then you can obviously use pi to get the radius. So
I like pi. Peach is my favorite.
Yeah. So,
but in any event,
of course.
But if it doesn't, if the trigonometry doesn't work and there are your triangles, QE, tell me where it's wrong. You have to disprove trigonometry or I'm right. So unless you can disprove trigonometry, I'm right. Yeah. It's as simple as that.
Yeah. And the funny thing is, I brought up that point that if you're multiplying an angle measurement by some, set distance, like 60 nautical miles per degree, you only thing you can get from that is a curved arc length.
Yep.
And that's, that's the part where I mentioned arc, and they did no idea what I was talking about. He went off on something about the arc, on the sextant, as if that's what I was talking about. And I'm like, you don't honestly know what an arc length is? I actually sent Brian's Logic a thing to a definition and a little calculator for arc length, so he could see exactly. And the nice thing is, you can put in a radius. You could put in. I gave him what the radius of the Earth is in nautical miles, so you can see if you put that in that little calculator and then pull the angle around, you're getting exactly the measurements that we get. If you pull it to 25 degrees, it'll give you 1500 as the answer in that little calculator. And if you put it to 50, it'll give you 3000, so it's like, that's the part they're missing, some of these key geometric, things that would help them understand the issues. So, that I was just thinking, like, if I could put this out there to give them something to think about, that was my goal. And surprisingly, I at least got it. I got that image out there for longer than I thought it would be. I didn't think that
it was up there for a third of the show, I thought you said.
Yeah. So that was actually.
This is a classic thing that you'll see in the flat Earth, and that is that, they'll look at this image and they have no idea how to read this. They have no idea what this image even means.
They were like, oh, look, he's posting a triangle. He's agreeing that there's a triangle. I'm like, I'm posting a triangle to show you that your thing doesn't work. Brian's Logic actually, at some point, reposted this with a laughing emoji. Like he thought this was ridiculous, not understanding that's like, this is the contradiction in your interpretation.
Yeah. Well, you have to understand, the biggest problem that you run into is if you want to debunk a model, you have to understand it first. Mm-hmm. And I'm finding that there are some people that have a pretty decent, I've tested a few flat earthers using Simon Dan's basic science test for 11-year-olds. And most of them have done pretty well so far. There's been a couple that have absolutely no idea what the difference between potential and kinetic energy is. They had one that actually brought up Kepler's laws and correctly answered a question, which amazed me. But, and then others haven't. But, they have such basic misunderstandings of trigonometry and geometry. They can't comprehend that. Well, how'd you get an angle from the center of the Earth? By measuring it at the surface, you dolt. Come on, it's basic. If you have two parallel lines, one is parallel to your tangent line, at where you're standing, you can make a parallel line straight underneath that. The angle to the star from both those lines is exactly the same. They can't comprehend this basic, the basic mathematics of it. And they make up for it in aggressive stupidity. They are willfully ignorant when it comes to a lot of these things, and then they try and turn it on you. They try and put you on defensive and claim that you are the one that is wrong, yet we know the math, they don't. We understand the model, they don't. Well, in any event. Yeah.
I was just going to say, I learned early on the value of a little bit of humility and willing to ask questions when you find someone who knows something more than you, because that has got me very far in life in learning new things. So,
there's always somebody that is smarter than you, that's richer than you, that's better looking than you, that has more influence than you. All right. The key to it is do the best you can for what you have and get to know those people. One of the things that I did as a doctor, quite a bit, I'm a pretty competent internal medicine physician. And there are times that I need some help, or there are times that patients feel the needs, do you think you really ought to send me to a specialist? Well, no, I really don't. But since you brought it up, I happen to know a really good one. And, the definition of a specialist is a guy from out of town. And so you send him over to the specialist, and the specialist says, well, hey, Dr. Bob did a pretty good job with you, and I'm going to have to try and figure out something else to do that he hasn't already done. So he'll order a stress echo, for example. Okay, well, the next patient that I send him has my regular workup and a stress echo. So now he's got to think of something else. It's a little game I play with them. But I learn something from every interaction that I have with somebody like that. Because there's always somebody out there that knows more than you do. And you clearly know a lot more than these yahoos do. And they wasted that opportunity by trying to play gotcha games and trying to put you on the defensive and put you, quote unquote, on trial. You know.
Yeah, that was amusing. Yeah, I will say that Huey is, if nothing else, he's entertaining.
Yeah, he is.
So, and I think it frustrated him that he never really got under my skin. He would fling insults at me, and I just never really.
I laugh at him. I laugh
So.
at him, and that drives him absolutely insane. He doesn't get under my skin. I find him amusing, and I find him a great source of information. One of the things that I learned early on is everybody you interact with has something to teach you. They either teach you what to do or what not to do. And what QE's benefit to me is that he shows me where the scientific reasoning goes wrong. You can just watch his mind go off the rails. And then he says things. And it's because his mind went off the rails and he has a knowledge deficit to begin with, but then he tries to make some very poor scientific choices. Mm-hmm. And that's very good for an educator or a science communicator because you see where the misunderstandings are. And so I want to thank QE for showing me a new misunderstanding every time he makes a video. And I agree with you. He has some of the most creative insults that I've ever heard. Sometimes I just tune him in, kind of like I used to watch the news a couple of years ago, just to see what that fool says now. Mm-hmm. And it's just a laugh. Well, in any event, I want to thank you for stopping by. I hope you take a few minutes for your family tonight. I hope to have some more chats with you in the future. And I'm serious, I would very much like to have Adam Meekins or 10th Man or even Brian's Logic come on the show and just host a conversation between you guys, just maybe a coffee hour together. Mm-hmm. See if you can kind of work out some of this stuff.
Sure.
So, you have any closing words for the audience? And then I'm going to let you go.
No, I guess not. It's been an interesting journey, kind of looking into the flat Earth version of celestial navigation. I'm not sure how much more I'm going to keep diving into it, but I'm definitely here to talk to people about celestial navigation. I think I can probably continue working with some of the people like MC Toon, and definitely would talk to you about some of the sextants challenge we might create and some of that kind of stuff. So
I'm working on it. Honest to God, I've had crap weather for about 4 weeks.
Same problem I've had here. Went out and
I haven't seen a star. I haven't seen a star in 3 weeks.
Sorry, I was just going to say, the one night we had a few days ago when it was pretty clear, it was so cold. It's like we cut it short. Like I was trying to get at least a 2-star sight, and it was like that was difficult to do. So,
well, the problem that I'm going to run into is that I'm going to want to actually go someplace that you can see on a satellite. Mm-hmm. All right. I want to be next to a verifiable landmark. I'm going to take a 3-star fix using the bubble sextant. And I'm going to take a video of me taking the fix. And then I'm going to submit it to you guys. I'm going to have you solve it first. And if you solve it, I'll send you the information as to where I was. And then you can use it as you wish. But I've got to have the night to do it, man.
Mm-hmm. Yep.
All right. Well,
Look
you have yourself.
You again.
All right. Well, you have yourself a great day. Thank you very much for stopping by.
Yep. Thanks for having me. Take care.